Alright, this is number 13 on the test review. So the 13 information I give you is the number of miles traveled to work by different drivers is normally distributed with a mean of 48 and a standard deviation of 3. And then I ask you the percent of distances between 42 and 51. So again, just like with 12, assuming that you watched 12 beforehand, we want to graph out this bell curve as best we can, and then we want to figure out where 42 and 51 are before I can even start guessing on percentages. We know the mean, which is the middle of the graph, is 48, standard deviation of 3. So I'm going to add 3 and subtract 3 for my first standard deviation. 48 plus 3 is 51. That's good news, because that's one of the things we needed to find. 48 minus 3, though, is just 45. So while I did find 51, I haven't found 42 yet, so I want to keep graphing. 51 plus 3 is 54, so now I'm 2 standard deviations out. 45 minus 3 is 42. Now I've found 42 and 51, and I had to go out 2 standard deviations to find both of them. This is not as easy of a question as 12 was because it's not symmetric on both sides. To get to 42, I had to go 2 standard deviations below the mean, 2 standard deviations to the left of the mean. To get to 51, I only had to go 1 standard deviation above, 1 standard deviation to the right. So it's not going to be an exact answer off the empirical rule. We're going to have to do some work to find this. Just like with 12, I would start off by pointing out that the distance from 45, or the percent from 45 to 51 is 68%. Because as the empirical rule says, from everything within 1 standard deviation is 68% of the data. So I know that 68% is going to be part of my answer. Right, you can visually see if I'm trying to find from here all the way to here, 68% is part of that. The question now is, what is this little sliver right here? Because I need to add this part to 68%. Well, I don't know right now exactly what that little sliver is. What I do know is that from 42 all the way to 54 is 95% of my data, because that's 2 standard deviations in either direction. Well, if I know that from 42 to 54 is 95% of my data, and I know that 45 to 51 is 68%, I just need to pull 68 out of 95, subtract 68 from 95, and I'll know what 42 to 45 and 51 to 54 is, meaning from here to here and from here to here. I will know what both those together are. Well, 95 minus 68 gives me 27%. So I know that both of these pieces together equal 27%. I don't want both of those pieces though, because 51 to 54 is not something I care about. I only care about that little sliver from 42 to 45. But because the fact that it's normally distributed means that it's symmetric, I can take that 27% and I can divide it by 2. 27% divided by 2 gives us 13.5, which means each of these pieces here is 13.5%. So in order to find the full percentage between 42 and 51, I take the 68% from 45 to 51 and the 13.5% from 42 to 45, and together that'll give me everything from 42 to 51. In this case, giving me 81.5%.